We've been talking a lot about energy and the transfer of energy from one object to another. We're going to talk about momentum in Newton's first law, which is an object at rest tends to stay at rest unless acted upon by an outside force. An object in motion will stay in motion unless acted upon by an outside force. Science is about making predictions. So let's make some predictions. I'm going to take this ruler and I'm going to set it, let's see, a ruler is 12 inches long in the United States. So I'm going to set it here at 5 inches remaining out here and 7 over there. Now what will happen if I take my finger and smack that ruler down?
It'll fly.
Which direction will it fly?
That way, that way.
It'll fly that way. Who wants to do it?
Me!
Everybody. Okay, go ahead, Bash. Just flick that. Whoa! So it did the same thing every single time, right?
Yep. Yeah.
And that's physics. Now let's change the conditions. I'm going to put a mass on the end of this ruler. I'm going to put this one sheet right there.
It's going to make it harder to go.
It's going to do what?
It's going to make it harder.
So your prediction is that this will make it harder because we've got a mass over here. And what do we know about a mass at rest? What does it do according to Newton's first law?
Makes it heavier.
Yeah, that. A mass at rest will tend to stay at rest. And so we've added more mass, so it's going to take more force to move that mass, right? Now we're going to put more mass on it. Put on 4 sheets of paper. Okay.
Hit it.
5 sheets. Don't worry about breaking it. Wow.
You got the first one.
As we add more mass, what is happening? What's happening as we add more mass? It's becoming resistant to change. Right? As we're adding mass, let's throw it all on there. Let's put this box of paper on it. Oh, no. Too dangerous now, guys. Ready? 1, 2. So what's happening? Why isn't it not breaking? Because it's flimsy. And what does that do? It's absorbing the energy, right? Instead of the energy going directly to one spot, it's spreading the energy out through the flexibility, which is why it's not breaking. What if I take it down to that point? Now I've used up all the flexibility, right?
Yeah.
So now it can't absorb all that energy. That energy is going to be directed right there. So what happens if I press down real hard now?
It breaks. It's going to break. Or not. Oh, yep, there we go.
Before, when we were putting less mass on, the force that we were applying was moving the mass, right? But we got to a point where the mass was too great to move. So instead, the force was directed to the ruler instead of moving the mass. The next card on a glass. And now I'm going to put a mass on that card.
It's going to fall in.
Form of
That's not heavy enough. That's not heavy enough.
Okay, so let's make a prediction. What will happen if I flick this ruler onto that card?
It's gonna go, and that thing's
Obviously,
gonna fall.
Montana made a prediction because she moved out of the way. So she didn't even have to say what her prediction was going to be. Okay, Creed, you're blocking the thing. So, okay,
The coin's gonna. This is gonna fly out, and the coin's gonna fall in.
That's going to fly out and the coin's going to fall in. Okay, why is that going to happen?
Because this, it's getting hit, and this is just staying in one spot, and it's heavier than this. This is gonna slide out.
And so a body at rest tends to stay at rest unless acted upon by an outside force, correct?
Yep.
So this is going to stay at rest, but why? I'm giving it an outside force, but it's still going to stay at rest.
Because it's a heavier mass than this.
Okay.
Let's go.
All right.
Boom!
Okay.
Let's go.
All right. The quarter did move, right? Which direction did it move?
Down.
It moved down. Why? What force was acting upon it?
Gravity.
Right, exactly. What would happen if I moved it slowly?
It would come with it.
It would come with it. Why is that?
Because it's too slow. Because it's not enough force. It's not enough force in.
Okay, because I didn't exert enough force to overcome the friction between the card and the quarter. So that force was transferred to the quarter, right? What do you think we can change in order to get different results?
Could we put like a card and then put a card on top of it?
Okay, let's give that a try.
Card.
Card, quarter,
Card on top of it.
card.
Okay.
There you go. Try that.
Can I do it?
Yeah, go ahead. Come on.
I want the champions too.
Hey!
Hey!
All right.
It's pretty
The energy was still transferred to both of the cards,
Turn.
while the quarter mass resisted the change. What if we got a card wet?
Okay.
Can we try that? See what happens? We're doing the exact same experiment, right? The only thing we've changed is we made the card wet. Are we going to get the same results?
No.
No. Okay. Let's see what happens. Yeah, this one's all right. Here we go. Ready? Okay, let me try it again. Let me aim a little better.
What? The card went in too.
Yeah.
That's
So why is that?
Because it's bending and
It's bending. It's absorbing some of the energy because it's not as rigid.
Can I try?
So it's absorbing that energy. What other reasons why are we getting different results? Because we wet the card.
It's sticking to the cup.
It's sticking to the cup, so we're increasing the friction, right? So we're not transferring as much energy and we're increasing the friction. We did add some mass to the card by adding water, right? So it's going to resist being moved as well more than a dry card, correct? An object at rest will stay at rest until acted upon by a force.